All right, so our first video for this unit is looking at physical and chemical changes. So our learning goal for this note is quite simple. You should be able to identify a change as physical or chemical, and I'm going to show you how to do that based on a bunch of different properties. So first of all, physical properties. Physical property is a characteristic of a substance that can be determined without changing the composition of the substance. So the substance itself does not change. So examples: color and luster, conductivity, if we can see if something conducts electricity, the density, the ductility, so whether or not it can be pulled and shaped into wires, how hard something is it, can you mash it in between your fingers, or is it really, really hard like a metal? Malleability, can it bend? And viscosity, how thick that substance is if it's a liquid. Okay, so those are all examples of physical properties, because regardless of what we do to those things, we haven't changed the substance. So if I pour some water, it's still water. If I bend a copper wire, it's still a copper wire. So all those things don't actually change the composition of the substance. Chemical properties, on the other hand, are characteristics that are determined when the composition of the substance changes. So you either make one or more new substances. So, for example, how a substance reacts with something else. How a substance reacts with acid. How a substance reacts with heat or light. Okay. All right, so physical changes, therefore, if we look at this is a change in which the composition of the substance remains unaltered and no new substances are produced. So, examples. If I break a pencil in half, it's a physical change. It's still a pencil, it's still made of wood and lead, but now it's just broken into two pieces. So breaking. Dissolving. If I dissolve sugar in water or salt in water, it's still salt dissolved in water, so I haven't actually changed the substance, I've just dissolved it in water. Melting, or changing state, so going from a solid to a liquid, or a liquid to a gas. If I melt ice, well, it's water in solid form or it's water in liquid form. I haven't changed the substance. Chemical changes. These are a change in the starting substance or substances and the production of one or more new products. So examples, if I burn something, I create something new. And the big thing is that a lot of times these changes are not reversible. So once I've burnt a candle, I can't go back and unburn it and bring my candle back to its original state. Baking, or exploding. Okay, so if I bake a bread, or bake a cake, or bake cookies, I can't reverse that. If I explode something, I can't reverse that. Digesting, when we digest food, we can't reverse that. And rusting, so rust on a car, again, cannot be reversed. Photosynthesis and cellular respiration are also chemical changes. All right, so this is the key here. What is the evidence of a chemical change? How do you know when a chemical change has happened? There are 5 key indicators of a chemical change. First off is a color change. The new substance has formed with a different color than the original. So if you see that, it's probably a chemical change. An odor change. New substance actually smells and makes a detectable odor. So when you light a match and you blow it out, you can smell the smoke, okay? So that's an evidence, an indicator of a chemical change. Gas production. If you make a gas, or you see bubbles that are not from boiling, you know that a chemical change has happened. If a precipitate is produced, that means a new solid is formed. I showed you that reaction when I made that gooky yellow stuff in class. That's an indicator of a chemical change. And an energy change. If heat or light energy is released or absorbed, then you definitely have a chemical change. So those are your 5 indicators. You need to know those because you need to be able to tell me if something is a chemical or a physical change. So if we kind of draw these, if we sort of draw these chemical changes in, if we change color, so you might have something that's green, and then I would change it, and maybe it changes to a different color. So that would be color change. Okay. Odor, maybe when you do the chemical reaction, it gives off some smelly odors. Gas is produced. That's usually seen when you make bubbles. So you can draw that in if you'd like. So gas is the bubbles. A precipitate. Precipitate is formed when you see some gooky solid at the bottom of your container. And energy change, that would be something like it feels hot. If it feels hot or cold, it's absorbing or releasing energy. Or if you maybe see, I'm not a very good drawer, but you might see something actually light on fire, so you might see like a flame. Okay, that could be an example of an energy change. So energy change is hot or cold, or some sort of energy being produced. So did you get it? So let's see if you can do these on your own. Is this a physical or chemical change? Is frying an egg a physical or a chemical change? Boiling water in a teapot, physical or chemical? Burning a candle, physical or chemical? Cracking a plate, physical or chemical? Painting a wall, is that physical or chemical? The color change in leaves, is that physical or chemical? Mixing milk and sugar into your coffee or tea, is that a physical or a chemical change? And rust on a car, is that a physical or chemical change? So we'll take up those answers in class, and that is all for today.